Hi, everyone. Today's lesson brings us to the real number system. In the directions, I had requested that you had a piece of paper and pencil so you could record some definitions. If you did not grab a piece of paper and pencil already, I suggest you press pause and grab one prior to watching this video. Okay, so here is the real number system. The real number system is a set of numbers that include all rational and irrational numbers. And you can see in this diagram, we are broken into rational numbers and irrational. Notice they are not included. Irrational numbers is a completely separate rectangle from the set of rational numbers. Let's first talk about the set of rational numbers. Okay, what are rational numbers? Rational numbers are numbers that can be expressed in the form of A over B, or kind of A divided by B, where A and B are integers and B does not equal 0, because you cannot have 0 in the denominator of a fraction. This basically means these numbers can be written as fractions. They do not need to be presented to you as fractions, but they need to be able to be written as a fraction, and we'll talk more about that. Let's get into the first set of rational numbers. There's a specific set of numbers called natural numbers. Natural numbers are rational numbers. Your natural numbers are also called counting numbers. They are all of your whole numbers that are greater than 0. Basically, it does not include 0. So as you can see here with these examples, it starts with 1, 2, 3, 4, 5, etc. And this includes any way you can rewrite any of these numbers. So we can write these numbers as a fraction. I can write the number 2 as a fraction. Any whole number, all you have to do is put a 1 as the denominator. So 2 over 1 is 2. Therefore, it's a rational number. If you can rewrite any of these numbers as something else, like 2 squared. Well, 2 squared is 4. So that's a rational number. So it's rational. And then you can write it as a fraction, 4 over 1. The second set of rational numbers are your whole numbers. Whole numbers are all of your natural numbers. So if you can see the set of numbers, natural numbers, that rectangle is included inside the rectangle for whole numbers, because all of your whole numbers are natural numbers as well. Your whole numbers are all natural numbers starting with 0. So they include all of these numbers, 1, 2, 3, 4, 5, and going forward, and also include 0. This box just includes some other ways where we can write these numbers. 4 over 2. 4 over 2 is 2, or it's written as a fraction, so you know it's a whole number or a rational number. Square root of 25. If I took the square root of 25, I'd get the number 5, because 5 times 5 is 25. That is a whole number and a natural number. Therefore, it's a rational number because it can be written as a fraction. 5 over 1 is 5. Also included in your set of rational numbers are integers. Now, if you notice, the rectangle labeled natural numbers and the rectangle labeled whole numbers is included inside the box or the rectangle of integers. Therefore, natural numbers and whole numbers are also integers. Your integers are your set of whole numbers. And don't forget, natural numbers are also whole numbers, and their opposites. So this is all of your numbers, 0, 1, 2, 3, 4, 5, going forward, and their opposites. So, and their negatives. -1, -2, -3, -4, -5, etc. So notice within the box, the rectangle labeled integers, I've included some of your whole and natural numbers with negative signs in front of them, because they are all of your whole numbers and their opposites, meaning the negative versions. Finally, we get back to our rational numbers. I've already given you this definition, but I'll read it again. It is numbers that can be expressed in the form of a fraction, where the numerator and the denominator are integers, and the denominator does not equal 0. Notice these are all fractions. 2/3, 1/2, 5/8. Now this is a decimal, 0.37, but this is 37 hundredths. That's how you would read that. 37 over 100 would be the fraction version. This is 0.75, but if I would read that decimal correctly, it's 75 hundredths, which means I can write it as 75 over 100. So easiest way to remember what a rational number is, any number that can be written as a fraction. Over here to the right are your irrational numbers. Now, irrational numbers are numbers that cannot be written as the ratio of two integers. Easiest way to remember it, cannot be written as a fraction. One of your ways you've learned to write ratios in the past, you could use a colon, you could use, or you could write it as a fraction is another way. So it's just one way to write a ratio, but it's easiest to remember it as cannot be written as a fraction. So we have a few different examples of irrational numbers here. And for this lesson, you are going to need to use a calculator to get you through it. I will write something or leave a video in your stream talking about calculators and how to use your square root button. But you can see we have the square root of 10. That's how we would read this number right here. This is your square root symbol, and this is called the square root of 10. If I took the square root of 10 on my calculator, I would get 3.16227766, and that's what fill up the whole line of my calculator, but it really doesn't end there. If I took the square root of 1.6, I would get 1.264911064, and then it really does continue on and on and on. That's just as far as it can fill up my calculator. The square root of 2/3 would be 0.8164965581, and it continues on from there. The negative square root of 123 is negative 11.09053651, and it really does continue on further from there. If you've noticed in myself giving you the decimal representations of these numbers, whenever you're talking about an irrational number, they are non-repeating, non-terminating decimals. So what does that mean? A decimal that there's no pattern. It doesn't repeat. It's not like 0.3333333333. That is a repeating decimal. Or 0.15151515. That's a repeating decimal. Irrational numbers will not have that. You're going to get just a bunch of numbers, nothing repeating, and they non-terminating, so it never ends. Now, that's the decimal form. Whenever you see, and I'm going to get to a slide in a few minutes that explains this a little more, these square roots, and we're going to call them square roots of non-perfect squares. These are irrational because when you take the square root of them, they're going to be non-repeating and non-terminating. Let's talk quickly more about the set of rational numbers. Just a quick visual to help you see that any type of fraction is a rational number and its opposite, meaning the negative version of it as well. So we have 4 sevens and negative 4 sevens, 1 and negative 1, so on and so forth. Any number that you can write as a fraction. So terminating decimals, because they represent fractional parts, are rational numbers. So any rational number can be expressed as one integer divided by another integer, aka it can be written as a fraction. Irrational numbers, all right? There's some examples shown here. Pi divided by 4, square root of 3, because this is not a perfect square. We're going to get to that in a moment. Pi itself. You guys know about that, about pi and how it's 3.141592683, and it goes on, and you know that it goes on forever and ever and ever. So whenever you think of irrational numbers, think about pi and the fact that you know that pi is a non-terminating, non-repeating decimal, and that will help you remember what an irrational number is. Irrational numbers cannot be expressed as a ratio of two integers. They are not rational, and they have decimal expansions that do not terminate or do not repeat. So let's quickly go over these non-perfect squares. So to kind of explain non-perfect squares, here's a list of perfect squares. Your numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, just a small list of what are called perfect squares. And why are they called perfect squares? Basically, because when I take the square root of them, I get a whole number answer. So the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. You can read the rest for yourself. These are called perfect squares. So don't think that any number that has the square root symbol over it is going to be irrational, because that's not true. If you take the square root of what are these perfect squares, they're rational. So this is where you need your calculator to help you. Any number in between these are irrational. So if I have the square root of 2 or the square root of 3, those would, if I took them, the square root of them in a calculator, I would end up with these non-repeating, non-terminating decimals. Therefore, they're irrational. And you can continue in between. Square root of 5, square root of 6, square root of 7, square root of 8 are all irrational. But the square root of 4 and the square root of 9 are rational because they are perfect squares. Square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, square root of 15 are all irrational. But in between, or square root of 9, square root of 16 are rational because when I take their square roots, they are whole numbers, and these whole numbers can be written as fractions. Your calculator is going to be your friend through this. It's really going to help you determine if a number is rational or irrational. So not every number is a perfect square. If they aren't, we call them non-perfect squares. To find the square root of a number that is not a perfect square, we use estimation with perfect squares, and we'll get to that on Wednesday. So you have an assignment to do talking about rational and irrational numbers. Hopefully you took some notes through this. If not, you may need to listen again through this video and take some notes on these definitions, because you're going to have a few fill in the blanks. Good luck. Let me know if you need anything, and don't forget to use a calculator. If you don't have your own actual calculator, there will be a post in the stream on Classroom with a calculator and how to take the square root of something, because that's mainly what you're going to need it for. Message me if you need any help.